So we've heard quite a lot about automotive and RISC-V, and Frank actually gave quite a good shopping list, I guess, of what they're looking for. I'm going to bring together a panel which is going to talk about some of the realities. I mean, I've heard quite a lot of news and written quite a lot about some of the RISC-V architectures going into automotive, but I wanted to sort of dig down into some of the reality of that. So I'm going to call on stage Balaji Bhakta of Ventana, Charlie Su from Andy's Technology. You take your seats on the, you have your nameplates there. Itai, Yarom from MIPS, hello. Andy from SiFive. And who have I got? Peter, where's Peter? Peter, you just heard from him. So, thank you all for joining us. And I'm going to take a seat next to you and ask you some questions. And hopefully you'll give our audience bits and pieces of snippets of answers that they might want to know. So let's start off by just getting a little bit of an intro so that everybody knows who you are, what you're representing, and some of the areas that you're working on in RISC-V in automotive. So who shall I start with? Maybe I'll start at the end. Andy.
So hi, good afternoon. My name's Andy Frame. I'm responsible for automotive as part of the product team in SiFive. Been at SiFive for just over 2 years, but spent most of my career with another successful IP company based in Cambridge in the UK. You can guess who that might be.
I think we all know. It's been mentioned. Peter.
Thanks. My name's still Peter Lewin. So I look after the CPU ecosystems for imagination. So it's looking at all the other companies we have to work with to develop software and the rest of the supporting infrastructure for our RISC-V CPU roadmap.
Hi, I'm Balaji Bhakta, founder and CEO of Ventana Micro. We had a keynote speech this morning introducing Ventana. Just to quickly give you a recap for those who haven't heard the speech. Ventana Micro is leading the high-performance RISC-V space with world-class processors that are achieving performance parity with ARM and x86 variants. So, bridging the performance gap with RISC-V, bringing chiplets, and bring in accelerator capability that allows hyperscalers to automotive customers innovate. In terms of Ventana, we have one of the best teams that does this, and we've been doing high-performance data center class processors. And as automotive architectures move to zonal, become more software, more compute, what we do becomes extremely relevant. Within Ventana, we have a team that has done this before. We've assembled a team of experts that have done automotive type work, so look forward to having a good chat here.
Indeed. Charlie.
I'm Charlie Su. I'm the CTO and president of Andy's Technology. We also have a keynote speech just before the lunch. So Andy's is a 18 years old pure play CPU IP company for automotive. So we provide a full line of processor from very small MCU all the way to data center, auto core. And for the automotive, about I think 2020, we passed first ISO 26262, the process certification, and using that process to start to design the process at the product. And we have a first product is certified, and the next one will be coming very soon. And then we have a full roadmap of code to kind of expand from a COB to a COD and so on, and also populated to a different performance segment. So I think we're going to have fun on automotive.
Thank you. Itai.
Hi, good afternoon, and thank you for coming to the session. My name is Itai Yarom, and I'm handling the sales and marketing for MIPS. And MIPS is a US company located. We have design services both in US and India, but a less known fact, or we keep it as a secret, we have also a design team in Europe, in few locations. So if you're looking for work or looking to do interesting stuff, look on the website, we have open positions. I think all of the companies have open positions, very interesting companies. And we are doing automotive for some time. Recently, we announced publicly about Mobileye adopting our CPU and working to do a level 2, level 3, and level 4 kind of solution based on our RISC-V CPU. And we, over the years, have optimized our solution both for high performance, but also for safety. And there are new challenges going to safety in smaller geometric and other application that requires new techniques and new capabilities going forward.
Thank you. I think all of you are probably looking for talent. We heard it from Roger. Send me your CV if you have this particular skill, so that's quite good. Let's go into a little bit more of what we've heard during the day. I think we've heard from 3 of you during the day today on keynotes on some of the areas you're working on in automotive. Callista Redmond this morning opened and she's talked about, she indicated that there was some market data from 2021 that suggested RISC-V will capture 10% of the automotive market by 2025. We're halfway through that time frame. Do you think that's still where it's heading, or is it more, or is it less? And what gives you the confidence for your answer? For example, is it based on design-ins you already know about or are coming into play? We heard from Frank that they're looking at things coming into 2028. So there's still a big time gap. I guess maybe Itai, you're talking about Mobileye and what they're doing, but are they actually already using RISC-V, or is that something that is looked at? And then maybe we'll ask some of the other panelists as well.
So I think the question is similar to a question when there will be an autonomous car. Is it 2021, 2023? So
okay.
It's
not really, but yeah, I see what you mean. Yeah,
it's a different way of looking at technology because the autonomous car technology is ready, but maybe we are, as a human, not ready to have autonomous car driving among us. I think on RISC-V, the challenge is the cycle of adoption. We already see companies like Mobileye adopting RISC-V, and we have a few other RISC-V automotive customers that are adopting RISC-V. Mobileye publicly announced that their product will be available starting 2025, and probably in mass production after that. And I think the other customers are talking 2025, 2028, and 2030. So I would say that probably a good amount of numbers is more around after 2025 in the automotive space. But on the other end, you can look on companies like Mobileye that have over 60% or 70% of the ADAS solutions. And if you look in that and when it transitioned completely to RISC-V, as they did with the Linux transition, started in 2020, and now all the systems, I think most of the systems they're selling is Linux-based. So in that case, you have 60% dominated by RISC-V in the ADAS space, and as everything gets more centralized, then other RISC-V elements and other things will be, RISC-V can become even by 2030 the dominant platform for automotive.
Okay. Charlie, I think you talked about being the industry's first RISC-V ISO 26262 fully compliant core. So where do you see this heading in terms of reaching that 10%? Where are you? What are the things that you think are indicating that might be the case?
I think that 10% or 15% or 20% is really difficult to say. I address this from 2 angles. The first is that I think in 5 years, we're going to have like 20% of core supporting automotive. That's kind of from our product development perspective. That's kind of 20%. And in terms of market traction, what we have is always kind of starting from the most entry level because that's easier. The environment is easier, deeper embedded, easy for customers to do adoption, and that's what's already happening in our product line with N25F-SE. In Asia, we see a lot of customers very interested in RISC-V. But it's just that they kind of starting from product requirement kind of everywhere. We are not able to cover all of them, so that's why we're putting the roadmap there. I think in US, in Europe, I think that probably a little bit more conservative, but hopefully that can be, once we get more solution from everyone, that market can get push forward and get faster. We certainly hope that Bosch at 2028, that schedule can kind of pull in a little earlier.
Okay, that's interesting. Balaji, I think I've heard quite a lot from you over the last year or two. So tell me a little bit about what you see in terms of reality of that figure.
Thank you. I would probably have a slightly different take on it. If you look at the mind share, it's huge. If you look at sum total of all of the existing sockets, it may be a different story because these other ISOs have been around a lot longer. But if you really measure the impact that RISC-V has within automotive space in general, it's bigger than we had actually thought, Ventana. We've been working with all of the leading automotive OEMs in Europe, USA, Japan, Korea, as well as in China. And if you look at that, you can peg them into two categories, in my opinion. Vertically integrated automotive OEMs and OEMs who buy modules from the module manufacturers. So if you go through the module manufacturer-driven cycle, yes, 5 years is quite realistic because they have to first pick a vendor, put it into their system, go through their qual and safety, all of that, and then the end OEM will productize it. So it takes that long. But if you look at vertically integrated OEMs, their development cycles tend to be far shorter than the traditional automotive cycle. So I think that's the important distinction that we've learned working with these guys. And the second thing is geography matters. In certain geography, they're a lot more conservative in other geographies. That's what we are learning without going into specifics. So they have the freedom to choose certain things that are not as mission critical, but they bring comfort and usability to certain brands. So there, you're not compromising the safety, but everything else is, basically giving them infotainment and giving them other features that they really care about. So if you go into those areas, certain geographies are adopting RISC-V far more aggressively than others. So I would kind of split it into, what Calista said is factual, in my opinion, based on, who you're talking to. So if you take into account some of the other geographies, that number could actually be spot on.
Yeah. In fact, you talk about geographies. I was at the Future of the Car conference in London just recently, and Geely was very aggressive in their plans, and obviously they've been quite acquisitive as well. So I think probably you don't have to say, but I can guess where the geographies are, where they're going to be a little bit more open to looking at different architectures.
Exactly. Yep.
Peter.
So I think whether 10% is an accurate figure or not is pretty difficult to say. Apart from anything else, is how do you measure that? If you if you think about the number of different CPUs that are in a car, they're not all going to change to RISC-V in the same generation at the same time. So if you're counting the number of vehicles that have a RISC-V processor, it probably is realistic. If you want to count the number of processors, well, is that actually units or the value? So that's kind of difficult. So the exact 10% seems reasonable. I think certainly a significant proportion of within that time frame sounds sensible. And then again, you've got to look at, well, are you talking about the design-in or when they're actually shipping? And yeah, I'll certainly echo the geographic thing. In some regions, then RISC-V is going to be adopted a lot quicker, both due to moving quicker and being more motivated to move towards RISC-V.
Andy, last but not least.
Yeah, so I think similar to what Pete said, you've got different levels of complexity in all of the devices in the car, and so it's probably more likely that the less complex ones will move faster. But also, I think what you've got is, compared to where mobile, you've got quite a large base of designs that just incrementally change. Whereas, I think someone said to me, the automotive industry is the new sexy industry because everything's changing very quickly, and it's the industry to be in. And I think, if you were to pick an architecture for a new part of technology as the car is evolving, then you would probably pick RISC-V. So once you've made that choice, things will move very quickly because you're not having to migrate code as much. I think the other thing to take into account is the maturity of some of the safety FUSA requirements. So everybody knows the requirements because the industry's been around for a very long time. But you know, as some of the newer parts are coming out, they have to go through functional safety accreditation and stuff. And so whilst things don't appear to be moving, obviously there's a lot happening underneath as products are getting designed in and becoming functionally safe, but you haven't seen them necessarily arrive yet. I mean, you know, we get pressured to do early drops of the products that we launched last year because people want to get them into products in the earliest model year. But you know, once again, think about design times for cars. You know, some of the OEMs are looking at 2028 cars and 2030 cars. So, you know, what you'll see is big jumps, I think. So it won't be a slow, steady. It'll be big jumps as a whole kind of product line and vehicle model will just switch. Interesting.
It is going to be quite gradual, but just a little snippet. Last week, Jensen Huang in Computex in Taiwan of NVIDIA, he said, there's only a market of 100 million cars anyway, so what's the big deal?
Yes.
He didn't say what's the big deal, I said that, but yeah, it's quite interesting.
It's like saying that replacing a horse or faster horse with the engine will just change the car and not change the city, the way we live and things like that. So I think when objects start to move, it's more than just having a car.
Yeah. I will say, if anybody does have a question, just raise your hand, and then in between things I can take a question if you've got a burning question. But let's go on. We talked about the market. What evidence do you see from what you're seeing with customers in terms of that time frame? Maybe if anybody wants to talk about some of the things that they've seen with customers that say, yes, this is really happening. RISC-V is happening in automotive. Balaji?
The one thing we see is traditionally automotives differentiated themselves based on speeds and feeds, right? And mainly ICE. And as you move from there to the next generation,
SDVs.
Exactly. So there is an architectural opportunity for them to do things differently. They don't have to go with the more traditional incremental steps. So that's number one. Number two, since they can't differentiate based on 0 to 60 at 3 seconds or whatever, they have to find other ways to differentiate, be relevant, still be able to charge the kind of money they charge. So, which means they have to innovate. Cars are nothing but servers on wheels, running sophisticated software, delivering user experience. So when you go to that space, everything is going to be different. So when we talk to all these OEMs, the first and foremost is, I don't want to be beholden to the same silicon guys giving me the same silicon, and everything looks the same, and I become a metal bender. They want to move away from that, which meant they have to adopt a software platform-centric strategy where they can differentiate features, functionalities. So, which means you have the opportunity to do RISC-V plus DSA. Why? Because other ISOs don't let you do it. You need to innovate, you need to differentiate, you need to have an opportunity to create something that's different, which means you got to have an ISO that lets you do it, which is where RISC-V really shines. So those are the kinds of things we see.
Okay. Anybody else want to add to that?
Yeah, certainly. I'd say from the type of conversations we're having, where you go in to see a potential customer and you think you think your job is to sell them on the benefits of RISC-V. You are more and more finding they're already sold on the benefits of RISC-V. They're telling you why they want to move to RISC-V, and it's down to the details of how they're going to move, how they're going to solve this problem, which bit of IP you have, and so that just that initial kind of, do you want to do this, almost seems like a question of the past, and it's moved much on to the how and the detail, and the how do we move forward.
You've killed my next question.
Oh, I'm sorry.
That's fine.
There you go.
Yes, Charlie.
So I think the RISC-V advantage in automotive space is not too much different from elsewhere, because RISC-V is open, so we have so many different vendors, so customer has multiple choice, extensible, so you can adding instruction, do acceleration to domain-specific architecture, and also there's a lot of embedded space, which in the old time people probably want something to be mature, stable, so they pick the other A brand, but RISC-V kind of come into this space very quickly. So kind of from the bottom, those don't need to use ARM, now they pick RISC-V. And on the top end, they need innovation, which RISC-V can come into place. I think that happened to play out very well.
I would say that also, if you look on the previous presentation by Bosch, looking on the trend on the market, so there's a lot of consolidation going from many ECUs to more software-based, like Balaji said, and there's a lot of moving to EV and all kinds of differentiation based on software. I think car OEMs want to have the control, or want to have the ability to develop different software component and deploy that in many cars, regardless of which CPU IP or which other companies are running the hardware below that. So having RISC-V as a way to collaborate, have a faster innovation, and even speed the pace of having new features or adding new feature while the car is already deployed. So the typical car is targeted to be in the market like 15 years from the day you sell it to the day you stop using it. And usually it's even longer. But I think today car companies looking in a way to extend the capability to add new feature, to update the software, to load new software, new capability into the car. And RISC-V give those companies the ability to innovate, to use different software component, and have ability to run those software components regardless which engine are being used. And I think maybe it's killing you future questions, but looking on the RISC-V responsibility is for us to try to provide a unified kind of consolidated profile or type of instruction set that is common in the car infrastructure. So regardless which CPU or which application, you can easily port different type of software to different elements of the car.
I'm going to pause to see if there's any questions. I don't see any hands up anywhere. No? Good? Well, not good. Yeah, I think the next question was going to be, and I think I'll sort of rephrase it a little bit, but Balaji, you talked this morning about the semiconductor innovators' dilemma, and especially for automotive, how you're going to differentiate. You know, they're all using the same processor, same bits of software, whatever on top. How do you differentiate? Now, I think what you've all just said is, yeah, RISC-V allows you to differentiate, and then you've also said that the attitudes of, and I'm not sure if you said it's the OEMs or it's the tier ones that are changing, and who cares? Is it the OEM? Is it the tier one? Is it the silicon vendor? Who is it who cares about that architecture?
All of them. I mean, literally, but in terms of who really cares about it the most, it's the OEM who's actually creating a product, branding it, and selling it, and commanding a certain price for it. Because those are the ones who really care about how their product is being perceived. And then they create a platform that evolves. And when you create a platform that's going to evolve, you need an architecture that lets you do it. If you don't have an architecture that lends to that kind of flexibility, you're going to be spinning new chips every 2 years, 3 years, and spend $300 million doing a 5 nanometer. That's out.
That was clear on your slide.
Exactly. And to Peter's point, if you can come up with an architecture that gives you a safety island that takes care of everything that's must not fail, mission critical aspects, confined to a block, and let that be the slow evolving block. Let the other block that's going to be more ASIL-B centric, that can evolve as the OEMs create their own multi-tiered product category. Everybody has the same basic software platform, but then they create multiple tiers, so they provide more and more features and differentiate prices based on that. So if they can have that ability to do it using this non-safety island, you have the, that's where I think this is going to go. Otherwise, everyone is going to look and feel the same. Today, if you go look at it, allow the fact that Mobileye is formidable, but not forever. It's going to change. So when that does change, the OEMs want to be able to bring in their own refinement to the ADAS algorithms.
Yeah.
They don't want to be beholden to one vendor that does it. So when you look at those kinds of things, RISC-V makes sense, and architecture is going to evolve for sure.
But that implies that the OEMs understand RISC-V, so they're coming to asking specifically for other architectures, because in the past it wasn't like that.
Absolutely. If you look at it traditionally, in the past, OEMs did not really, when I say this, maybe tongue-in-cheek, they didn't really care about the microcontrollers that powered their embedded systems.
Exactly.
Okay? They took it for granted because that came from vendors who knew how to deliver them in a predictable way. And those things did not change. Your braking system did not get re-innovated every cycle. It was what worked, was allowed to be there. But when it comes to software-defined vehicle or transportation as a service type models we are getting close to, a lot of software is going to be there, a lot of innovation that couples the edge with the centralized provisioning system, those kinds of things. So those things really need to have cloud and edge orchestrating in a manner that you've never had to deal with in auto before. So those kinds of things will require you to do these kinds of new innovations.
Andy, you're going to say something.
So I think software is probably one of the biggest issues. So it's not just about the software-defined car, it's about software for all parts of the car. And the single ISA kind of component of this is really valuable because it means you can use a single tool chain. You can have a single experienced team of people who don't have to know all of the different proprietary architectures or multi-ARM architectures on an SoC, for example. But I think something that's really critical is the being able to get back a little bit more control of destiny for the auto guys. Because what you used to get, many, many years ago was where you had a silicon guy and an auto guy, and the silicon guy basically responded to what the auto guy's requirements were. It was like, okay, we need you to do this, so okay, we'll design it in the next product, and it was available. When you got into the more ARM-based world, it was, we need this new feature. It's like, well, does it work well in a mobile phone or a data server? It's like, well, not really. Okay, well, see you next year then. Whereas with RISC-V, what we have is the extensibility, so people can actually add that stuff actually into the standard, or they could, take some kind of early lead and actually differentiate, and then make it a standard when things progress. So, kind of these things are what are becoming more appealing to the auto guys who've kind of got themselves into a bit of a rut. Proprietaries kind of run out of steam. Where they've landed is maybe not where they want to be, and just having a little bit more control and saving costs in terms of software development is, the door's quite honestly open for when we go and see customers. Yeah.
Does anybody want to add anything?
So I think certainly everyone needs to know in the OEM part, I think especially in Asia, they are quite aware of the RISC-V. So they specify they are chip vendor, they need to do RISC-V. In Europe, I don't know, but I think the tier one, Bosch also give a very good example. It actually a little bit surprised me. They asked for the capability of adding custom instructions. So I think they probably also know that that's kind of a good way for them to do innovation, but beyond what they can do in the past. So so I think from Andy's perspective, we are kind of pretty big into custom instructions, so we definitely be there to help them when they want to innovate.
And I think that means you're doing a good job in awareness. But Itai, you're going to say something.
Yeah, I have two notes for your comment. So I think first, if you look on countries like Japan compared to Europe, the government is putting a lot of money supporting the local industry to transition to RISC-V. So this is a government push, and then they have the kind of companies like Denso have their own chip development, partly funded by the government, partly funded by the industry, to have tier one ability to adopt even a chiplet kind of approach. So I'm looking at Europe as a leader that recently, I think, if you look on safety engineer, China is now become the leader of the world, and Europe, Germany is like number 3 after US, and Japan is in the last, in the 4th place. But looking on Europe, I think there's a good opportunity for Europe to invest in RISC-V. In automotive, European car manufacturer is still very desired, very leadership in the worldwide, and I think this is the opportunity to take the market and really invest there. I think the other comment I have is that the chiplet ability to do is something that is happening already. It's not like a wishful thinking. This is a way to build a solution that is scalable, and Mobileye and other companies are using that. So they're using like 2 chiplets for low-end kind of entry-level ADAS, and then they're using like 16 or more kind of combination thing to have some robotaxi or autonomous delivery in some section of the city. So it's thing already in deployment, and it's extending to become more than just a pilot. But so it's not a wishful thinking. The automotive industry is really looking at a way to accelerate this.
And I think a couple of weeks ago there was a conference where there's a whole chiplet ecosystem for automotive established. Can't remember who it was, but Mercedes-Benz is one of those as well. So,
If I may.
yes.
As a matter of fact, I was going to actually mention that if you're looking for a definitive proof point, look at the initiative from the industry leaders trying to form this UCIe for auto.
Yeah, that's the one, yeah.
So if you look at it, there are things like, can we create an auto-centric UCIe chassis architecture that allows plug and play between multi-vendor chiplets doing different functions. So the auto industry is actually moving forward and creating some chiplet-based implementation scenarios that could bode extremely well for everybody.
Yeah?
That's another really tangible proof point.
Yeah. Peter, did you want to add anything? I've got a question from the floor here, so before we go to the question.
I would have the question.
So I have one here. I'm not sure whether you're supposed to go to the speaker or whether you can speak loud enough to the microphone, or whether you can speak loud enough to ask the question.
Can I try?
Yeah, give it a try.
So building on what Andrew said before, we talk a lot about hardware, but also about the importance of software. So is the software capabilities, the tools, kits, and so on, are they keeping up with the development on the hardware front? Thank you.
Okay. All right. Did you get that? Is the software keeping up with the hardware?
I can answer.
Okay.
So this is a very good question. And for the automotive software, there are different requirements than other software, like data center, things like that, that also reliability is important there. In automotive software, you want the ability or the requirement for the certification is that you use the top of the tree kind of software. And also in compilers, you need to have multiple compilers that come to the same from safety point of view. So this is something that if you manage it correctly or have a compliant kind of profile, this is the way of working. On the other side of the benefit of the RISC-V is that the pace of automotive software company like Android for infotainment system, Green Hills, all these kind of components, if are adopting RISC-V and supporting that, it's much faster than I saw in any other platform in general. So the amount of software enablement is growing very fast, and this is very encouraging in actually going to the 10% or more kind of number.
Yes. Yeah, Balaji.
So, software, in terms of the maturity of the software ecosystem around RISC-V, you're absolutely key. I mean, you're absolutely correct. That has to keep up with the same, if anything, it has to be ahead of the hardware by quite a few quarters. So you can, so to that end, we at Ventana have spent a lot of time looking at software ecosystem for autos proactively. And, you got to have the tool chains. You got to have the Linux distros that the OEMs really care about. And if they they want to have some kind of RTOS, you got to provide for that. And on top of that, hypervisor. So XYZ, for instance, is a piece of hypervisor code that auto cares about. The maintainer of that code is a Ventana employee. So, in terms of software ecosystem, we've been very mindful of the question that you just asked. Without that, you're not going to see the kind of explosive adoption that we could otherwise see. So yeah, it is important. And I think most of the RISC-V vendors that, including my peers here, when I talk to them, everybody focuses on it. As a matter of fact, if you look at, there's this software group called RISE, that stands for RISC-V, software ecosystem. They do have a focus around all of that, including auto-specific software components. So yes, it's important, and we're paying attention and keeping up with the needs of the OEMs.
Does anybody else want to add? Charlie?
Yeah, so RISC kind of focus on open source, but there's already a lot of commercial vendor for the all kind of stuff, from the compiler development tool like Green Hill, IAR, and also there was Misra kind of checking tool, Parasolve, LDAR. In my keynote before launch, I showed a couple of the partners for that. And also very important is Autos, Safe Autos, and also the AutoSAR, for example. Vector is probably the big one for that, and also Siemens is also on that. So we are talking to them, bring that to our customer, and so you name it. So those are important stuff. We already get the information from the OEM, especially in Asia, so we can build up that. And it, with OEM behind that, actually the ecosystem build up very quickly.
So in previous architecture shifts, I've always seen this as a bit of a chicken and egg problem, right? I've always described you have to have the hardware available before anyone will port software to it. You have to have the software available before hardware can be deployed. And so it does that kind of flywheel that turns up. Where I think I've seen a difference with RISC-V is the kind of the buzz about it. So from a lot of the software and the AutoSAR vendors, you're seeing some, we want to get ahead of the game. We want to make sure that we are the software vendor who's seen as supporting RISC-V when that hardware becomes available and when that gets deployed. Now, the exact level of commitment and the exact level of development going on there may vary, but there does seem to be a willingness and a drive to get that support in place ahead of the hardware, which maybe hasn't been the case for other architectures in the past.
Andy?
Yeah, and I think what this the leading edge for the ecosystem is, this is a new revenue stream from them as well, right? That's where they they've been kind of gone from multi-architecture support to kind of honing down into one with different variants. But the opportunity to kind of renew a revenue stream is interesting. What you're finding though is you might not get an ecosystem vendor particularly backing one RISC-V IP vendor because they don't want to show favoritism. So they'll kind of come out and say we're more of a RISC-V rather than, so it's, once again, it's that maturity level again because products are only just coming to market, I think. So I think what you'll see is a big hockey stick with the ecosystem support for.
But I think that will be addressed by the open source software sitting on top of that, and then it won't be just that one. I think somebody talked about fragmentation earlier, so I think it's quite interesting. Do you want to add, Itai, or no? We have one question here and one question over there. So please say who you are, by the way.
Yes. I have one question about ISO 26262. Most of the time people are summarizing that by being ASIL-D, but actually there's another condition. And it's moving from fail-safe on the version 1 to be fail operational. And unfortunately, the actual computing architectures were, I'd say, lasting before the actual ISO 26262 norm, meaning that they cannot achieve fail operational. You have to stall the application, run some DFT, so it's actually creating issues when you have real-time operation, especially for level 3 and level 4. Do you think there's an opportunity to adapt both the hardware and the software around the RISC-V to enable the RISC-V cores to be fail operational in terms of safety mode?
Is that kind of a re-architecting question then?
Yeah. Adapting potentially the ISAR to be compliant with a fail operational safety mode, which is actually a requirement for the norm.
Who wants to take that?
I can say, okay.
So,
No. All right, who wants to go first? Right.
Okay, so I'll let Pete answer why on RISC-V, I guess. But I can say that we are actually over the time learn how to put more than just the bare minimum thing on the safety. We have special mechanism to help to recover for a safe state. We have also ability to reduce the adoption. So when you deploy a car, you need to do different type of testing before you can start to sell it. So we, by having some special characteristics of safety in our solution, enable actually the OEMs to save like 6 months to drive tenths of the amount of kilometers they need to drive to deploy the card. And this is, you can look like in Mobileye True Redundancy, how they use these kind of features. So it's something we are sharing, and we are very happy that we are not the only company doing automotive. Actually, there's many of us. And I think it's not something unique for RISC-V, but on RISC-V we can collaborate between the companies and actually provide a solution that is more robust and address more things. And I would say that also there will be the post-lockstep kind of era, because when you go below 3 nanometer, lockstep is not enough, or safety island is not enough. You need to look on other challenges or other abilities. And we have, I gave a talk, I think, a week ago in some event about automotive, talk about some other ability for redundancy and other ability to do efficient way of achieving ASIL-D without the sacrifice of duplicating everything. So, and also looking on lockstep and 3 nanometer, you need to get some asymmetric kind of operation to protect against high geometry. So it's not something coming very soon. 5 nanometer is only now getting mature. 7 nanometer is what got mature a few years ago. So I think it will take time, but this is areas we actually look to see how we accelerate the automotive space. And I think with our other partner of the RISC-V, we'll see this actually accelerating different type of product, a different type of solution.
Peter.
Yeah, so I was just going to mention that we've got 2 special interest groups within RISC-V looking specifically at this. So there's the Automotive Special Interest Group, which I chair and Andy is vice chair, again to look at what improvements or what changes and what developments would make it easier to adopt RISC-V. So that can be changes to the ISA and additions to the ISA, or it can also be stuff around the ISA, different standards, anything else to help develop that. And in addition to the Automotive Special Interest Group, there's a Safety Special Interest Group which is looking at safety more widely. A large part of that is automotive, and that's Yarom shows that special interest group, and we're involved and working together on that. So yeah, certainly trying to highlight those places where software and hardware can be developed together to improve that is a good opportunity. It's not clear where to go with it at the moment.
Okay.
But
I have a question over there.
Yeah, so I'm Thaddeus from Tins Torrent. So a lot of the message about RISC-V in automotive is that there's a lot of flexibility, you can innovate, you can do all the things that you want to do, yet at the same time, in automotive, when you deliver a product, you have 10, 15 years of supportability and liability responsibilities. I'm curious to know if there's anything that the SiFive community can do, whether it's about safety, whether it's about reliability, that can actually help with this burden, or are we all individually going to be responsible for all of that support of flexibility?
Thank you. I was with your colleague Julie in Taiwan doing a fireside chat last week. Yeah, what do you think? Who wants to answer that?
You know, I think if you look at it, that question was answered quite a few ways. But if I were to look at it, your traditional auto architecture is different than the ones that we are talking about that are driving the growth opportunities.
Yeah.
So if you're talking about the new architectural shift, namely zonal, that everyone talked, I mean, Frank was able to talk about it in a lot of details from Bosch. So for those kinds of things, you're going to have, and also I think Peter was also highlighting that if you can move if you can create a safety island in which you're going to capture some of those mission critical building blocks, and then if the rest of it can grow independent of that particular island, innovation can happen. So that's how this thing is going to grow. And more than just theoretical analysis, if you take a look at the kind of engagement we're seeing from all of the OEMs, they're all jumping in to try and create RISC-V based products. And these are all people that are doing IVIs. And so I think the proof is in the pudding. They are putting resources behind that. And there are areas where you can do RISC-V without actually compromising any safety aspects of a vehicle. So yeah, I think there is an architectural bifurcation that's beginning to happen. RISC-V is well poised to take advantage of it.
Okay.
Yeah, just to continue that one, I think you know, some of the more kind of conservative parts of the vehicle, then you're not going to get massive amounts of innovation, I don't think, because you know that level of safety requirement has to be deterministic, etc. So, but I think you know what you'll see is more experimentation in some of the newer areas, but then less safety conscious. So it's not a problem, I don't think. I mean, the other thing to think about is, you know, it's not just the automotive industry that's looking at RISC-V. Even, you know, the European Space Agency and NASA have determined that RISC-V is going to be around for an awful long time. So they're going to be spending.
It's going to be in that satellite, isn't it?
Yeah, it's the, you know, the next moon exploration is going to be using RISC-V because you know you've got this flurry of expertise coming out of universities. So you're going to have people around who know this, and you know, I think it's when you have extensions to an architecture, then they become long-term supported. It's if you kind of want to do something niche, which you wouldn't do in something in a real-time, you know, safety system. I don't think.
And that's the differentiation then. Yeah.
First, I would say that, like in the moon system, the satellite that they took picture of Pluto used MIPS, and the reason they did it was they wanted to deploy it first before the NASA will cancel the project. So they wanted to. And I think one other thing that related to what you're saying is that we're going to see the RISC-V enable safety company, security company to come with a solution, not just a service, that around the RISC-V core, because of the RISC-V, they can use open RISC-V core or some RISC-V architecture core and provide a more complete solution that it's not just a service, but it's also a solution, like a security block, a safety block, and because it's only two of us here, well, I can say there will be new announcement in that coming in the coming future.
I mean, you've already got that with verification and things like that. So we saw with Imperos earlier and whatever. But anybody? I think there's another question. I don't know. Do you have a question?
Sure.
Yeah, please.
So my question is that most of the automotive development today is mostly software. What we understand is AutoSAR and those groups, some names were mentioned there too. They drive all the development, right, in the sense of the software writing, correct? So if you look at a parallel, on the server space, ARM is being talked about, the enemy, ARM is being talked about, but there hasn't been too many of ARMs in general available today, and the whole story is software. I wonder whether between the ARM and RISC-V, software would be the driver on massive adoption of that technology. Everybody is wanting RISC-V, so that is one question. And I think one of the, I don't know, we call it an advantage, is that when you do extension, you'll have to come up with a compiler for that extension, and who does it would be pretty much drive in the auto industry. So that's one. The second question I'm asking is, we are only talking about four-wheel cars. The rest of the world make more than 100 to 200 million two-wheelers every year, right? And now there is an extension for 26262 for two-wheelers now, right? So motorcycle version, M version. So how do you see that market? Because that's far easier to adopt than the other one, right? So those are the two questions.
Interesting angle, the two-wheelers. So first part of the question was AutoSAR.
I can say that, so AutoSAR is one aspect, like we talk about Vector and Mentor now, Power Siemens doing the AutoSAR. It's one aspect of sharing resources for the software, and the software complexity is increasing. It's becoming 100 million kind of line of code, but it keeps on increasing and going to be 10 times larger in the next 10 years. But I think there's other way to share resources around CPUs and using, I think it was mentioned here as well, hypervisor and things like that. So I think it's going to go into this area. And for two-wheelers, there are similar things. There is Mobileye, it's a different name, I forgot the name, doing for two-wheelers, for this other type of application, for personal mobility. So, like I say, it's more than just moving cars, it's moving objects, or the city is moving. So it's enable hotels to move rooms and things like that. So it will be interesting.
So this is going to be our last question because I think we're out of time. But anybody else want to add to that?
Well, I just want to say on the two-wheeler side, I have had conversations with OEMs with motorbike manufacturers, very interested in moving a lot of stuff over to RISC-V. Their take on it was that in the past they've usually used ECUs that were developed for automotive for cars and generations gone past, and then adapted the software and adapted them for motorbikes, and they were trying to get ahead of that curve and much more develop ECUs specifically for motorbikes, and therefore they were looking at RISC-V as a good option for doing that.
Balaji.
Yeah.
I believe there was also, first part of the question was, it took ARM so long to get a foothold within the data center.
That's right, yeah. And
what's the story with RISC-V and automotives? There's fundamentally big difference. Data centers are general purpose compute architectures. So the kind of infrastructure that you got to mature to drive any and all apps running on your data center is very different than automotive-centric architectures where all of the software is pretty much tested, validated, and run by the OEM with over-the-air upgrade capability. So there, the problem set is somewhat finite. And secondly, they've been at it for a lot longer. They're simply moving it from one architecture to another architecture. And most of that shift is happening around open source type basic infrastructure. So yes, it's somewhat compelling when you think about the capabilities that these autos have to have. Basically, they're going to be 3 servers or so on wheels. One that's going to do ADAS, one that's going to do infotainment, another one that's going to do telemetry and those kinds of things. So when you do that, the kind of software that they run there, even though it may seem like it's a server-like machine, it's first-party software, and that software is finite, and the OEM gets to upgrade it on their schedule. So they're not general-purpose machines like data center architecture. That's the biggest difference, and that's why the adoption here is going to be a lot easier, in my view.
Okay. On that note, I think everybody's itching to go and get the drinks, and we're out of time. So I'd just like to say thank you to the panel for a wonderful participation. Thank you. Thank you to the audience. Thank you.
Thank you, Nitin.
So a few highlights. So tomorrow morning at 8, there will be a breakfast panel that you can find in your program. And we'll resume the plenary session at 9 with a keynote by Luca Benini. And now you are invited to the cocktail reception in the booth area to connect with the community. Thank you.